Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P16BB, indicates a low voltage in the Alternator B terminal circuit for the Honda Civic models from 2006 to 2011. This error may trigger warning lights on the dashboard and may affect the electrical load management of the vehicle. Understanding the role of the alternator is crucial here. It is responsible for charging the battery and powering electrical components while the engine operates. It is typically located at the front of the engine, mounted securely to the engine block. The B terminal circuit connects the alternator to the battery and the voltage regulator, essentially ensuring the battery receives sufficient voltage while managing power distribution to other components. These components may include the vehicle's climate control, lights, and other essential electrical systems. When diagnosing this error code, it is important to perform a systematic troubleshooting procedure to ensure proper repair and electrical function in the vehicle. The error code P16BB is specifically associated with low voltage readings detected in the Alternator B terminal circuit within the Honda Civic model range from 2006 to 2011. This terminal is crucial for the functionality of the alternator, which plays a significant role in the vehicle's charging system. By supplying proper voltages, the alternator ensures that the battery remains charged during engine operation. Failure of this circuit can lead to inadequate power supply to electrical systems, causing performance issues or even complete failure of electrical components. The alternator itself is found at the front of the engine, and the B terminal connects it to various elements, including the battery and voltage regulator. Due to the importance of the B terminal circuit, addressing issues related to it promptly is vital for maintaining a reliably functioning vehicle. There are several possible causes for the P16BB error, which primarily involve electrical connectivity issues. First, poor connections can arise from corrosion, dirt, or wear, leading to an unstable electrical supply. Loose terminals can also result in intermittent electrical connections that lead to fluctuating voltages detected by the system, causing the DTC to trigger. Additionally, an open circuit within the B-line wiring can result from physical damage, wear over time, or improper installation of components, interrupting proper voltage supply. Each of these causes warrants specific examination during troubleshooting to ensure all electrical pathways are functioning correctly. Diagnosing these causes correctly hinges on visual and diagnostic checks to establish a solid electrical connection throughout the system. The symptoms associated with DTC P16BB can manifest as various warning signals for the driver. Commonly, warning lights illuminate on the dashboard as the body control module detects inadequate voltage from the alternator circuit. In addition to the illuminated indicators, drivers may experience failures in electrical components such as headlights, climate control systems, or power windows, reflecting directly on the alternator's ability to power such systems due to low voltage levels. A significant symptom includes reduced performance from the vehicle's battery, which may lead drivers to experience difficulty in starting the vehicle or frequent recharges. Spotting these symptoms early often leads to a more straightforward identification of the root cause and an effective resolution. The first step in troubleshooting DTC P16BB involves accessing the vehicle's ignition system. Begin by turning the ignition switch to the on/I position, ensuring that the vehicle systems initialize adequately while still not engaging the engine. Following this, the diagnostic software known as HDS, Honda Diagnostic System, should be employed to clear any DTCs present, including the P16BB code. Clearing the codes allows for a fresh start in the diagnostic process, thereby minimizing the clutter from past errors that may no longer be relevant. Once cleared, the next immediate action is to start the engine, which activates the alternator and allows for an operational assessment of the electrical systems involved. This initial step sets the groundwork for subsequent checks and diagnostics. After starting the engine, it's essential to replicate the specific conditions under which the P16BB error had previously been logged. The vehicle must be placed in conditions where the electrical load is significant, testing the alternator's capacity to deliver adequate voltage. Set the air conditioning system to on and adjust the temperature control to maximum cool, which increases the load on the electrical system. Additionally, setting the blower fan to maximum speed and activating the rear window defogger enhances the electrical demand on the alternator. Furthermore, switching the headlights to high beam creates further demand, ensuring a thorough assessment of the alternator's performance and the circuit's integrity under load. This simulated driving condition helps identify any anomalies related to voltage supply. During this third step, the engine speed must be maintained at 2,000 RPM while in neutral for a continuous duration of 1 minute. This allows the vehicle's electrical system, particularly the alternator, to function under controlled conditions, evaluating its performance under sustained demand. Consistent speed at 2,000 RPM permits the alternator to work optimally, ideally producing sufficient voltage under load. Once the minute has elapsed, it's time to check for any pending or confirmed DTCs using the Honda Diagnostic system. This diagnostic check reruns the tests on the system and assesses whether DTC P16BB is still present, indicating persistence of the problem, or if it has resolved itself. Continual presence of DTC P16BB at this stage calls for deeper investigations into connections and wiring as described in the next steps. Upon checking the vehicle systems for DTCs with the HDS, a determination must be made regarding the presence of DTC P16BB. If it is still indicated, this suggests that the problem remains unresolved, and it is necessary to investigate further. Checking for poor connections or loose terminals at the alternator and the underhood fuse/relay box is crucial at this juncture. Poor connections could result in insufficient voltage reaching necessary components, further perpetuating the cycle of failure. If the connections are indeed faulty, they must be repaired, as this might be the simple fix required to rectify the DTC issue. However, if connections appear sound, troubleshooting must move on to inspecting the wiring for faults. Next, the focus shifts to the wiring related to the B line, running from the alternator to the underhood fuse relay box. It necessitates a thorough inspection for any open circuits, breaks, or damages along the wiring harness that could disrupt voltage flow. This step is vital because even a minor flaw in the wiring can lead to significant voltage drops, exacerbating or directly causing the DTC P16BB error. If the inspection reveals that the harness is intact and operational, the conclusion may necessitate the replacement of the alternator itself. This step emphasizes paying careful attention to both connections and wiring to ensure all elements in the circuit are operational. A faulty alternator can fail to provide adequate voltage, failing to meet the electrical demands of the vehicle. The sixth step requires turning the ignition switch back to the on-to position to reinitialize the vehicle systems after either repairs to wiring or alternator. With the ignition on, the next task is to reset the engine control module, ECM, using the HDS. Resetting the ECM helps clear any stored parameters from the previous malfunction. Following this, performing the ECM idle learn procedure is crucial, allowing the vehicle's engine management system to recalibrate its operating parameters to establish an optimal idle speed. This step ensures that the engine's various sensors recognize new values after any changes in the electrical system. By completing this point thoroughly, you ensure that the vehicle has recalibrated correctly and is ready for further testing. Now, with the engine started once more, it is essential to recheck under the same specified conditions as before to verify the functionality of the alternator and electrical system. Set the vehicle's air conditioning to on, adjust the temperature to maximum cool, and ensure the blower fan is running at maximum speed. Additionally, turn on the rear defogger and the headlights on high beam to simulate normal operating conditions effectively. This environment stresses the alternator and verifies if the repairs have rectified the previous voltage issues. Utilizing the HDS, check for any pending or confirmed DTCs post-testing. If P16BB reoccurs, further investigation into the B-line connections and alternator status is warranted, returning to prior steps in the troubleshooting guide. Final verification of repairs conducted is crucial in confirming the success of the troubleshooting process for code P16BB. The initial indication of this DTC must be absent when conducting checks with the HDS, confirming the electrical system's integrity. It is advised to not only check for the absence of P16BB, but also monitor the overall health of the vehicle's electrical systems for any lingering abnormalities. Each component, including the alternator and wiring, must be operating within specified voltage ranges without re-tripping any error codes. Completing this final verification step ensures that the entire electrical system is functioning properly and provides confidence in the repairs carried out, assuring the owner that the vehicle is roadworthy and reliable. Preventive maintenance is pivotal to keeping the electrical system of the Honda Civic functioning optimally and avoiding repeat issues like those indicated by DTC P16BB. Regular inspections of all connections at the alternator and fuse relay box help preemptively identify signs of wear or corrosion that could lead to failures. Keeping terminals clean and tight ensures minimal resistance in electrical flow, which is crucial for vehicle performance. Additionally, routinely checking battery health plays a vital role. A weak battery puts extra strain on the alternator, potentially leading to issues if the alternator is constantly working to compensate for inadequate battery power. By implementing these maintenance strategies, vehicle reliability can be significantly enhanced, minimizing the risk of diagnostic trouble codes recurring. In concluding our examination of DTC P16BB, understanding the integral role of the alternator in a vehicle's electrical system offers valuable insight into its operation. The alternator must provide consistent voltage levels. Any issues in the circuit, whether from wiring or connections, can trigger diagnostic trouble codes indicating failure. During troubleshooting, it is crucial to systematically verify each component and connection while following the designated steps, ensuring a thorough diagnosis and repair process. Ultimately, awareness of preventive maintenance strategies provides assurance against potential issues arising in the future, helping maintain the confidence of owners in their vehicle's reliability. Keeping connections clean, monitoring battery health, and conducting regular inspections fortify the electrical system's long-term performance, ensuring many more miles of trouble-free driving. Please like and subscribe to the channel. See you next time.